Hi, Lacey. They're so embarrassed. This morning I called a student out. Like Wynn was not paying attention in trade class, and I'm like, Wynn is not paying attention. He's like, that's on recording. I don't care. Quit screwing around. Right. So anyway, you'll be forever. Your voice will be forever on this video for whoever wants to watch it. I don't know. All right, 0-5, adding probabilities. I already told the class that 0-6 is on the opposite side, okay? So this is all one note sheet, but we're only going to do 0-5 today. All right, I'm going to use a bunch of examples in class too, so I'm going to pick on a bunch of you, all right? Adding probabilities. So all outcomes are equally likely when something happens. All outcomes are equally likely in a simple probability model, I think. Hold on. Model used to represent the outcome of an experiment. Yep, simple probability model. I had to read through all the other ones. Simple probability model. Okay, the outcome that actually occurs. We've talked about this before. Maybe not. Okay, no, that was geometry class. The outcome that actually occurs and the outcome you expect to occur. Those two kind of go together, these two. Okay? One of them is experimental probability and one of them is theoretical. In the word theoretical, you hear theory. So in theory, what should happen? That goes to the theoretical probability. So the outcome that you expect to occur is theoretical. The outcome that actually happens is what happens in the experiment. So here's an example of that, okay? When I flip a coin, if I flip a coin twice, one time it should come up heads, one time it should come up tails, because it has a 50-50 chance, right? So every time I flip a coin, if I flip it twice, one should come up heads, one should come up tails. In theory, that's what should happen. Does that actually happen? No, because you could flip two heads, right? Or two tails. Not always does it come up one of each. It should come up one of each because it's 50-50, right? But in the actual experiment, it doesn't always do it that way, okay? So that's experimental probability versus theoretical, okay? The model used to represent the outcome of an experiment. A, probability model, and a measure of the chance that a given event will occur. C is probability, okay? So we've got probabilities going on like crazy here. I love teaching probabilities. You will have a lot of these on your maths test next week. Woohoo! We should know what we're doing by then, right? So, theoretical versus experimental probability. I just went through that, okay? This is what can and cannot happen for probabilities. When you're representing a probability, you cannot have something that is less than 0 for a probability. Like, it's not like a -4 chance or -4% chance that I'm going to roll a 3. That's not going to happen, right? That sounds silly, okay? In the same way, you cannot have like 150% chance that I'm going to roll a 3, okay? Anybody seen Mean Girls? Okay, where she's predicting the weather. I'm not going to tell you how if you haven't seen it, but you guys know, all right? She's predicting the weather, and she sits there and says, and there's a 108% chance it's already raining. I don't remember what it says. 108% chance it's already raining, right? Okay? That can't happen. You can't have a percentage that's over 100, but she's stupid and so it's funny, right? So over 100% when you're talking about probability does not happen. Over 100% does not happen. It's not like grades. You can still have a grade that's over 100% if you get extra credit. But probability is not the same thing, right? So as a decimal, 0% is the same thing as 0 as a decimal, okay? 1 is the equivalent of 100%, right? 1 is the decimal version of 100%. Does that make sense? Okay? 1/2. What's the percentage for 1/2? 50. Percentage is 50%. Okay, the decimal version is 0.5. Go back over that, please. I'm recording that now. See? Win. Really? Win. I was talking about you. I was. About how you're screwing around. All right, and case in point, now he's in my room because he's asking questions. Whatever. All right, so theoretical and experimental probability. I need to make my screen bigger, actually. Bleep. Theoretical. Okay, what is the experimental probability of rolling a 6? So this is what came up, right? This is what came up. Let's do part B first, actually. What is the theoretical probability of rolling 6? 1/6, right? I have a 1 out of 6 chance of rolling a 6. What is that as a fraction? How do you convert that to a fraction? 1 divided by 6, and it will do it. What is it? 0.16 repeating. Okay, you guys have seen that bar over the top. That means it goes on forever, which is basically like 16.67 if you round percent. It has like a 16, almost 17% chance of rolling a 6, yeah? 1 out of 6 times I should roll a 6, okay? Now, what somebody did was they sat and they rolled dice over and over and over again. And then they graphed it, which is off to the right, okay? That's what actually happened in the experiment, okay? So, how many times was a 1 rolled? 9. How many times was a 2 rolled? 6, then 12, then I think that's 6 again. 5 was rolled 7 times, and a 6 was rolled 10 times? It looks like 10. It's hard to see those lines, okay? So let's add all those up and figure out how many total there are. So 9 plus 6 plus 12 plus 6 plus 7, not 17, 7 and 10. What is that total? How many times did they roll the dice? 50, exactly. They rolled the dice 50 times. So, what is the probability of rolling a 6? How many times did they roll a 6? What was the chances of them rolling a 6? They rolled a 6 how many times? 10 out of 50, which reduced, please always reduce, 1/5, which is 20%. So, I should roll it 16 or 17% of the time. I rolled a 6 more or less often. More often than I should have, right? I should have only rolled it 16% of the time. I rolled it more often than that, right? 6 was my lucky side. Actually, really, 3 was my lucky side, but 6 was another kind of lucky side, okay? So, experiment is not always the same as what it should be. If everything was the same as what it should be, that would not be fun ever, right? There'd be no risk in anything. Okay? All right, so there's that. A simple event versus a compound event. Okay, an event that has a single outcome is a simple event, and then consists of 2 or more simple events is a compound event. Okay, so what you just did above was a simple event. We were rolling 1 dice. So I'm going to put here like rolling 1 die. Die is the plural of dice. So rolling 1 die. A compound event could be rolling 6 dice. Okay, let's do 2. Rolling 2 dice. Rolling 2 dice. Or more. I should say die here, not dice. 2 die. Rolling 2 die. Okay, or maybe you're drawing 2 cards. Or maybe you're rolling a dice and drawing a card together. Okay? So that would be a compound event, okay? Events that cannot occur at the same time are said to be mutually exclusive. Now this is where it gets confusing. Okay? We're going to talk about inclusive versus exclusive, okay? I want you to cross out this word where it says not mutually exclusive. Right in there, inclusive. I like to call it that versus not mutually exclusive. That's just too much writing. So you have mutually exclusive. What does it mean to exclude somebody? Like not including them. They're off to the side, right? Mutually exclusive. You have 2 bubbles that are not associated with each other, right? Inclusive would be they have some overlap, okay? So look at this. You guys know your cards? Can a card be a king and a queen at the same time? No, those are exclusive things. Exclusive things, okay? Inclusive. Can a card be a king and a spade at the same time? Yes. You have the king of spades. Here's all the spades. Here's the kings. You have 1 card that is the king of spades. Okay? So, scenario here. I'm going to talk about you guys. Can you be a junior and a senior at the same time? So what are those? Exclusive or inclusive? Exclusive, right? They exclude each other. There's nobody that is both a junior and a senior at the same time. Okay? Same thing with like males and females. Okay? Even though we're not going to get into that. Okay? All right? So, we're going to assume that you cannot be male and female at the same time, even though your guys are going to like, Wynn's back there. He was a terrorist. Wynn is a terrorist. Because he sits and like terrorizes my classes. So he was the kid that's like, nah, you can be a boy and a girl at the same time. He was that kid, okay? Don't be like Win. Don't be like Win, okay?
Quiet, and then I got naughty.
You did. I used to like him, and I don't like him anymore. For the last like 2 years, I have not liked him. He's not a nice kid. Okay? Don't be like Win, okay? So, exclusive versus inclusive. Okay, so now, girls and basketball players. Inclusive or exclusive?
Inclusive.
Can you have a person be a girl and a basketball player at the same time? Okay, so let's do this. Raise your hand if you're a girl. Marcus had to think for a minute. Okay, if you're a girl. Okay, now raise your hand if you're a basketball player. Do you play basketball, Marcus? Yes. Yes, okay. So that includes both boys, right? Boys and girls basketball players. If you raise your hands for both, keep your hand up. Put your hands down if you didn't raise your hand for both. You guys are the middle people. So Kelsey lives in Middle Land, okay, because she is both a girl and a basketball player. Marcus only lives over here because he is only a basketball player and not a girl. Woo. Okay. Over here, Rachel, you play basketball? You do? Josephine, are you gonna play basketball? You think so? Who's not gonna play basketball? It's a girl in here. Everybody's playing basketball? Lily! Okay, so Lily is a volunteer in this class. Okay, so Lily is over here in girl land, but she's not in basketball land. So she's gonna be the only one left over here, right? Because she's not in the middle land, okay? So now, here's the problem. If I say, let's talk about girls and basketball players here for just a second. So, I'm gonna do a little bubble over here. Girls, basketball. Okay, so let's talk about girls for just a second. We're going to include Lily in this, and we're going to include Win too. Should we include me?
Why are you including me?
Sure, we'll include me. Okay, so because we need more people. Girls and basketball. Okay, so in this class, including Win and including me, girls are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, did I count that right? 9. There are 9 girls. Okay? There are 9 girls. Basketball players. Raise your hand if you're a basketball player. Basketball player up high so I know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not you. No, not you. Okay, so 10 basketball players. Okay? Now, total in this room, there is 1, 2, 3, 4, 5, 6, 12, 14. There are 14 total people in this room. And you're totally confused because you're like, Mrs. Comerter, what are you trying to get at? Okay? So, here's what I'm going to ask you. What are the chances that I select any one person from this room and they are either a girl or a basketball player?
9, 14.
Okay? So, a girl or a basketball player. There is a 9 in 14 chance of me selecting a girl, right? There is a 10 in 14 chance of me selecting a basketball player. If I add those together, that is 19 over 14. But wait a second. I just told you up above here you can't have a number that's greater than 100%. 19 over 14 is greater than 100%. Do I have a 100% chance of selecting either a girl or a basketball player? Let's say I choose Clayton. He's not either one of those, right? So I don't have a 100% chance. So where did we screw up? Okay? Because I have a couple people that live in the middle land, right? Okay? So girls, there are 9. Basketball players, there are 10. If you are both, raise your hand. If you are both a girl and a basketball player, there are 1, 2, 3, 4, 5, 6, 7. 7 live inside of here, okay? So Mrs. K and Lily are the only ones in here that are not in the middle, right? Okay, so 2 of us are just over here and 7 are in here, right? That makes up all of mine, okay? So here is the problem. This is where we went wrong, okay? Kelsey, I'm going to pick on Kelsey because Kelsey was in both categories, right? Kelsey is both a girl and a basketball player, so she lives in here, okay? Kelsey's name and the rest of you 7 were included over here, and here, right? But Kelsey's only one person. Thank God there's not two of her, right? Kelsey is only one person, so she can't be counted twice because she's only one person. Same thing with Maya. Maya can't be counted twice because she's only one person. Okay? And the rest of you, 7. You can't be counted twice. So what we need to do is after we add these together, we need to subtract out the repeated people, right? How many people were repeated? 7. 7 in the middle, okay? So we're going to subtract out 7 over 14, yeah? And that's going to give me 12 over 14. I have a 12 over 14 chance of getting either a girl or a basketball player, right? Okay? So that means there's only 2 students that are not either a girl or a basketball player, and they're Clayton and who else? Mason, do you play basketball? Oh, no, it's not me. I'm a girl. Come on. Did you say we play basketball? Basketball? I messed up. Is there 11 basketball? I don't know. So Clayton is one of the ones that is not. I think there was 11 basketball players instead of 10. Whatever. We'll do another one. But anyway, we have to subtract out those people because they are counted in both categories, and that's the problem, right? And they're only one person. Okay, so let's do example down below. They say determine whether the events are mutually exclusive or not mutually exclusive, and then find the probabilities. So Tashika's teacher is randomly assigning students to a day to present their projects. If 8 students present on Tuesday, 5 on Wednesday, and 6 on Thursday, what is the probability that Tashika will present on Tuesday or Thursday? Okay, now, the first question that we have to ask, can you present on more than one day? Is this inclusive or exclusive? If it's exclusive, it's easy. Exclusive, because you're only presenting on one day, right? Tuesday, Wednesday, or Thursday. So we're going to write that first. Exclusive. So just add. If you are doing exclusive, you just add, okay? So how many students, let's see, how many students are presenting total? 8, 5, and 6. That is 19. 19 total, okay? So 19 total. We want to know the chances of her presenting on Tuesday or Thursday. So how many people present on Tuesday? 8. How many people present on Thursday? 6. And we said that we are not subtracting anything out in the middle because you cannot present on both days, right? So 8 over 19 or 6 and plus 6 over 19 is 14 over 19. So she has a 14 over 19 chance. What is that as a decimal or a percentage?
74%.
Basically a 74% chance that she's going to present on either one of those days, right? Because 14 over 19 leaves 5 people that don't present on Tuesday, Thursday. Is there 5 people that present on Wednesday? Yes, right? Does that make sense? So this is exclusive. You just add the 2 together. That's it. Okay, now, this next one. Suppose that, this gets kind of confusing. Suppose that of 1,400 students, 550 take Spanish. Or just 550 take Spanish. 700 take biology, and 400 take both Spanish and biology. Okay? 400 take both Spanish and biology. Okay? So, 1,400, just wait a second. 1,400 students total. I'm going to do that, and then I'm going to do my bubbles. Okay? So, this is going to be Spanish, and this one's going to be biology. Okay? All right, so I'm going to ask you some questions here. Spanish takers are 550, biology takers are 700, and then there's 400 that take both. Okay? 400 that take both. So, look at this diagram. I'm going to ask you a question. I'll give you a second to think about it. How many people take only Spanish and not biology? Okay, don't, just wait. Think about it for a second. How many people take only Spanish and not biology also? How many people take only Spanish and not biology? Josephine's got to figure it out. How did you get 150?
I don't know. Like 500 minus 150 minus 200.
Yes, if 400 of these people take both, that means there's only 150 that take Spanish only, okay? Knowing that, how many people take biology only? 300, right? 300 people, because 400 subtract out of that, okay? So now there's 1,400 students total, okay? So what we're going to do is they're asking for what is the probability that a student selected at random takes Spanish or biology. So we're going to do Spanish, we're going to do biology. The chances of them taking Spanish are 550 out of a total of 1,400, yeah? 1,400, okay? Biology is 700 over 1,400, okay? Now, hold on, before we do all this computational stuff, 550 plus 700, that doesn't add up to 1,400. Where are the rest of my students? Not taking either, right? There's an option to not take either Spanish or biology, right? Okay, so 550 plus 700 is 1,250. The other, 150 students aren't taking either one of those options, right? So don't be trying to add those up in your head and think like, where are the rest of the students missing? That's because, okay. So that is my chances, okay? I'm adding those together. But if I add those up together, that's not going to give me an accurate answer because 400 are counted in both categories. So what do I do next? Subtract out the middle. So I've got to subtract out 400. So I always set every single one of these up like this, right? You add the two outsides, you subtract out the middle. That's exactly how you do it every time. So add the two outsides, subtract out the middle. Okay? What do you get? My bottom number is going to be 1,400. What? 850. Okay, now do this. Lump off a 0. 85 divided by 140. You can reduce that by 5 at least. That is going to be 17 over 28 as a reduced number. Yeah, 17 over 28. What is that as a decimal? Or a fraction, or a percentage? What?
60%.
60%. So that means that if I go and choose any one student out of those 1,400, I have a 60% chance of choosing somebody that's in either Spanish or biology. Only 40% of the students are not in either one of those. Yeah? Does that make sense? Okay? All right, do we need to do another one? Just real fast. I'll do it off to the side over here. Wynn's like, no, you need to come help me. Okay? No? Are we good? You add the two outsides, you subtract out the middle. Okay. Verified homework is up there on the board. Woo! 1 through 10 all. Wow, that's really nice. Gosh, you're such a nice teacher that gives you like no homework at all. That's so wonderful. She's so funny. All right. What?
Mine's not.
Sorry, Lacey. Stop the video.
I was gonna say,